Alright, so first off, let's go over what you should be doing for your programming assignment that is due on Friday. If you're using the Replit, it should look like this. I forked it from the link that Mr. Simon gave, and maybe we will work through linear search. Okay. In this assignment, you're pretty much filling out 1, 2, 3, these 4 methods here, and then when you run the program, it will tell you whether or not your function is done correctly. It should be in the array or not in the array. So based on your searching, the first searching coding bat over here from last week, you're pretty much copy and pasting this code and changing it ever so slightly to work for this item object. So I'll demonstrate with linear search, the simplest one. So here's my code for linear search. I can copy and paste this code that's there, and let's migrate it over to this stuff. Okay. The for loop, this part can stay the same. I still have to cycle through my entire array. My array, though, is not called A in this example. It is called store. Okay, that's my array of items. So instead of going a.length, this part will change to score. Okay, I++, A becomes store, not score, store. Store. This is store. Okay, and does that equal target? Well, my variable that I'm looking for is not called target. It is cat num to find. And then over here, we notice, if I were to run this code, it would give me a type mismatch, because store square bracket I right now returns the item object, but we need to make a comparison with a integer, right? We're looking for its what's it called, category number. If we scroll down to that item.java, we have to get cat num. That's what we are looking at. Get cat num. So in our comparison, we must use the .cat num function, this member function, .cat num parentheses. Gotta watch my capitalization, so I gotta go back and check. Yep, that's it. Okay, now it's comparing a number with a number. We don't have that type mismatch like some of you did for your Game of Life assignment, where you had an object compared to an integer. And we don't return I. We need to return store I dot get, inventory. We are returning that number for this assignment. It's a function. Double check my spelling. Yep, get inventory. If we compare based on category number, we tell the user, oh, there's this many in stock. So that was what? 1 change, 1, 2, 3 changes from what was in coding bat to put it into this linear and binary search coding assignment. And now I think if I press run, I should see that the linear search test cases are okay. Let's find out. So give it some time to run. And at the very top, we should see this part. Cool. There is nothing of catalog 0, that's correct. Stock 184, it's the very first thing. Yep, 14 items in stock. Cool. 1996. 7, yep. So, ta-da, that's it. I demonstrated it with linear search. Hopefully you can figure out how to do this with the other 3. So, student that asked the question, does this help? Cool. Yep, you're welcome. So reminding you of using these getters because you're working with objects. That's the next layer of difficulty. It's not just numbers, they're hidden within this item object. This is how we work with them. Okay, so I can close this, I can leave that open. And then I can go here. ScoresSpecial was requested. The other one that was requested was words without. Huh? Do you mean words without list? No, words without at the very bottom, right? So words without was discussed in detail in block 1's video. If we have time, I'll go over that. But for now, let's start with ScoresSpecial. Woohoo! Here we go. The PowerPoint slide. All right, so again, I'll demonstrate and work through this in a ways that I want you to adopt. That is, not pressing the go button and peeking at their test cases, creating your own test cases, walking through these test cases, and playing computer on your own, so that you train yourself to approach this like a AP test FRQ. So given two arrays called A and B of non-negative integer scores, a special score is one which is a multiple of 10, such as 40 and 90. Return the sum of the largest special score in A and the largest special score in B. Okay. To practice decomposition, write a separate helper function, helper method, which finds the largest score in an array. Write your helper method after ScoresSpecial method in the JavaBat text area. Oh man. So you know this thing is ancient when it says JavaBat. A couple of years ago it was changed to CodingBat because it supports Python now. Old school days it was called JavaBat. Like when I took this course with Mr. Simon, it was called JavaBat. And this site has been alive since then. Okay, so advice as taken. Let's see. Find largest score. So find largest. This will be a function we will make as our helper as recommended. Is it necessary? Not quite, but it does certainly help you in organizing. Okay, so find largest, we need to give it an array, and then it should return the largest special, right? Yeah. Largest special number in there. It's not just the largest number, it must also be special. If we make a helper function on AP test and don't make it public or private, will they deduct points? Ooh, good question. Off the top of my head, I don't know. I do know that public and private declarations are, like, they're present in the FRQ rubrics. And I think Victor's right, they're public by default. And I think they care more about, like, the private variables. If they say variables should be private, they better be private. And I think there might be some wiggle room with public, because it's, like, less restrictive. That's something I will write down and take to Mr. Simon when we meet tomorrow, and I'll get further clarification. FRQ rubric. Okay, so let me get back to you on that. Okay, so where are we at? We're writing this helper function. We are looking for, given an array, let's find that special score. Well, if we're finding things in an array, we think of this like a linear search. You aren't graded ever on efficiency, so you could just linear search everything. They don't expect you to memorize and write binary search. All right, once we're inside our array, we're checking. Oops. So I started writing a for loop, and I also started writing an if statement, and then I realized, oh, I got to do a lot more work in here, because we definitely need to loop through the array. Now inside, we have to do some checking. Check to see if we got a special number or special score. So specifically, that is looking for something mod 10 equaling 0. That is a multiple of 10. Using mod to find multiples of 10. If you do find a multiple of 10, you don't return it immediately, because what if you have a bigger one, right? So it looks like we have to write our little variable here to help us hold that biggest number. You check to see now if is what you're currently holding as your biggest, well, how does my brain work? Okay, is my new potentially largest number bigger than my supposed largest number? It came out funny. Is the special score I found bigger than what I already have? If it is, answer must be updated to be that new special score. I think my logic is right there. Strictly bigger than? Yes. Okay. So this one, and if, and then down here, this one is end loop. Now this is the end of my end function. Cool. And then at the very end of my function, I should be returning that answer. Let's see. If I'm writing a helper function, I have to test it to make sure it works. So maybe I will walk through this first array here with 12, 10, and 40. It should give me this number 10. So my array here, answer is currently 0. My array length is 3. I check, is 12 mod 10 equal to 0? Nope. So I ignore all that. Then I go back and repeat. I go to the next one. Is 10 mod 10 equal to 0? Yep. So then we ask ourselves, is 10 bigger than what's currently my answer? Yes, because it is 0 right now. So answer equals 10. I go repeat this one more time. 4 is not evenly divisible by 10, so I don't store it. I return 10. Nice. Let's check something more complicated. 2, 20, and 30, I should be returning 30. A mistake to make is returning 20. Let's see what my code does. In my find largest special, using now this second array as my input, I should be seeing the number 30. Array length is 3. Array, the first thing, 2 is not a multiple of 10, so I don't do all this. I repeat. 20 is a multiple of 10, so 20 is bigger than 0. Answer right now equals 20. Then I repeat. I'm at position 30. 30 mod 10 equals 0. Yep, it's evenly divisible. Is 30 now bigger than 20? Yes, it is. So my answer becomes 30. Nice. Could I test this once more? I guess, but I think we've covered our cases here. Pretty sure. Might not, but I'm rather convinced that find largest special works as intended. Now that we've written this helper function, we can go back to our original problem. We have to do some kind of combining. So we're returning the sum of the largest special score in A and the largest special score in B. Cool. So we can say A largest equals something, int B largest equals something, and then we return their sum. A largest plus B largest. Something like that. And then here, this is where our helper function comes in, so we don't have to write the same thing and copy and paste and repeat it twice. We're calling our find largest special function. This first one applies to A. This next one, find largest special, applies to B. And I think that should work, right? 10 plus 30, it should give us 40. Nice. Now you see the usefulness of using a helper function here. Had we not, you would have found yourself repeating this code twice, once for the A array and then another time for the B array, and your code would be much longer. If you can find procedures that repeat, think about writing a helper function. If you got to use it more than once, probably write a function for it. And this is definitely allowed on the AP test and encouraged. Oh yeah, you can even do that, right? You can even write it even shorter and not have these two variables be here, and instead return these things. Even better. Return this plus this. Even more elegant of a solution. Ta-da! That would work too. Good observation. And so moment of truth. Let's clear it, right? So this is us submitting our FRQ to the College Board. Did I pass? Oh no, looks like I made an error with these incompatible types on line 5. What did I do wrong? Integer array can't be converted to int. Line 5. 1, 2, 3, 4, 5. What I do? Uh-oh. A of I, where? Right here? Inside the argument. Where's my type error? This thing returns an array? I don't think so. What am I doing wrong? Find largest special, returning answer, answer, answer. Oh, you're right, right here. Good catch. There we go. I meant for ARR to be an array, but here's the type mismatch. There, good catch. Yes, yes, very good. I wonder how big of a deduction that would be, because my code doesn't work, but the idea is there. Also another question to take back to Mr. Simon. Okay, let's see. Oh, yay. Good catch, team. Took me a while to see it. So that was what I was missing. Ta-da. Okay, other comments and questions? I'm double checking the time. We got 13 minutes. Looks like there will be enough time for us to review words without. All right. So again, try to not press go as much to practice like FRQ, etiquette? I don't know what to call it. To get the most out of coding bat to model that FRQ environment. I think on the online AP test, you're allowed to use a text editor. You could write this all out in processing and then copy and paste. You aren't expected to write everything by hand as you would in an in-person AP exam for APCSA. Writing code by hand is totally other beast because it seems to throw off some people. And I guess there's some technique involved into writing code by hand. Okay, so with this one, given an array of strings, return a new array without the strings that are equal to the target string. One approach is to count the occurrences of the target string, make a new array of the correct length, and then copy over the correct strings. Neat. On the AP test, this thing would not be there, this advice. It would just give you this prompt and likely some examples to go with it. Okay, so I like the approach though of the hint that was given, seems to make sense to me. First, we must find the occurrences of that target string. So in your brains, you should think of, that's a linear search, not with numbers now, but with strings. So gotta write a loop. Int I equals 0, I less than our array that we work with now is words, I++. So in this first part for my organization, this is find the occurrences, spelling doesn't count, of target string, just a comment. Int total equals 0. Right. If words at position I. Now, since we're dealing with strings, remember we got to use dot equals target total equals total plus 1. After this loop is done running, we should have found all the occurrences of like A, for example. I think later on it might be more useful to figure out what is not equal to the string, because that ends up being helpful in the second loop, but we'll see. All right, so we did the first part of this target. If you hear like scratching against the mic, or it's my buttons on my shirt rubbing against my computer, so I apologize about that. Make a new array of the correct length. Okay, so now we do integer, no, not integer, they're strings. So string square bracket, what is it, new array, call it answer, is of type who. Does it look like this? And then we got to tell it how many. Well, it's words.length, take away the occurrences of that target string. So in this case, it was 4 and then it becomes 2. You see it here on the second test case. If we're removing b, my new length should be 3. So here, this function, or this part, if it works right, it should have counted there was just one b, 4 minus 1 equals 3. Do you need new? Yeah, I think so. You're right. Because we're working with objects. Good catch. We need new here. Then copy over the correct strings. We're on to that third part. So when we're copying int I equals 0, we should be thinking, we got another loop. Come on, int I equals 0, I less than, well, still it's based on words, right? Words.length, I++. And then in here, we have to find now, instead of words, I dot equals our target. Now we actually want the opposite. If you're not equal to that target, then we copy you over to our answer array. Okay, so I wrote question marks here because it seems like we do need another variable to help us keep track of where we are in answer. So in the beginning, you start off at 0. Once you copy something over into the correct spot, then you move it to be 1 bigger. Why do we need this? Because like in this example, you skip over b. Words ends up being at position 2, but you need to copy that into your answer array into position 1. So they may grow at different rates. Think about it like skipping and accounting for that. And I think here is my end I loop. At the very end, we return that answer array of strings. Okay. Shouldn't we skip the other array though? Well, notice the difference in size. I'm not quite sure about the question. It's of size 3, not of size 4. So we can't leave it like A, nothing, C, and A. Oh, sorry, +1. Is that what you meant down here in this line? I forgot the +1. Okay, so that exclamation mark is there. Let's go ahead and try to test it out in this test case here. ABCA, bring out my annotation tool. So before I press go, let's check it in my brain. Let's see if this works for this one. A, B, and C, total equals 0. I'm looking for C. Words.length is 4. We check to see everything in here and see if it's equal to C. Words.target of A, does not equal my target, skip. B doesn't equal my target, so skip. C equals my target, so total equals 1 right now. Neat. Bringing that into the second one, my string's length right now should be 3. There are 3 spots. Like that. Where did we get 3? Well, that's 4 minus my total of 1. So over here, good question. So you still need to process each word in words. You'll see it here. So now in our for loop, my length is still 4. My answer array is of size 3. We start checking now. words I. Well, that's the letter A. We ask ourselves, is A equal to my target of C? Flip that logic. It is not equal, but we flip it because of that exclamation mark. So this one ends up being true. A is not equal to C. So inside answer position currently is 0. We put the letter A here. And then we update our answer pos to be 1. So now that we're looking here and ready to copy over the next number, we repeat ourselves. Now we check the letter B. Is B equal to my target? No, it is not. So we copy it over in position 1. We increment it, so now answer position is now 2. We check. Here's the moment of truth. There's our C. Is C equal to C? And then you flip it. Oh, this part, C does equal C, but since we have that exclamation mark out in front, it flips it. So we skip the copying and then we go on. Our I is now looking at the last A. I is equal to 3, but notice my answer position is still at 2, waiting for me to copy something into this last spot. And you should see that A does in fact get copied here. And we're done. I tested one test case out loud. You should probably do that here. Like in this case, answer position was 1 behind because it didn't skip. But words array, it needed to be skipped. I needs to process everything regardless. Okay, let's see how we did. Fingers crossed. Cool, all correct. Ta-da. If you get a star here, a student asked in block 1, those were from the built-in coding bat problems. If you solved all the problems in that particular set, it gives you a star. These problems are custom made, so you don't see a star here. All you need to see is that green check mark. Okay, that's it. No other requests. You're welcome to stay and treat these next 3 minutes like open office hours. Otherwise, you all are good to go. Enjoy the weekend. I'll see you on, I think Monday might be a holiday, right? Or is it tomorrow a holiday? I forget. See you later. Bye.